It's a fatty.
Recording. It's recording.
Mara, no violence.
You're right, okay.
I know.
I'm making promises.
All right, maximum and minimum problems is what we are up to. So just a reminder that when we do things, if we local maximum, I can't spell, and local minimum, that's just in the area of the graph, just in a particular area. But so in that location. But then there's another one that we could say absolute maximum. And that would refer to the actual maximum value across the whole domain. All right, so just be careful, be aware that those things mean slightly different. The local maximum may be the absolute maximum, but not necessarily so. All right, and of course minimums can be thought of, excuse me, minimums can be thought of in the same way. So, like for example, if I do this sketch here, so this sketch here, this function is from -2 to 4, including, and let's just say it's fx equals x squared plus 2. And then when we are looking at this particular one, we know it's what sort of graph? Parabola. What else about parabola? What's this 2 to translate it? So it translates it up 1, so turning point, sorry, up 2, yep, sorry. So the turning point is now here. All right. What we also need to know is where the endpoints of it are. And because we've got a domain here, we can use those x values. So f of -2 would be -2 squared plus 2, which would be 4 plus 2, which would be 6. So this is definitely not to scale. And then the 4, the other end, f of 4 would be 4 squared plus 2, which would be 18. So it's most definitely not to scale. So it's up here. And then we now have the bit of the parabola that looks like that. So if they're talking about what's the absolute maximum of this parabola in there, we need to look at the graph, and we see that the highest point's over here. So the absolute maximum would be 18. So the absolute maximum. Is 18. All right, and the same, we've got a minimum point here, and so in this case, the minimum point is the absolute minimum. It's also the local minimum in that area. It's also the turning point. So they may be more than one thing. All right, one more example. I'll rub all that off.
Up to the sort of notation stuff.
I don't know then. All right, to rub the lot off now.
Is there a -3 on that little,
Where did I, what?
on the bottom there?
Where?
No, it's -2.
-2. -2
It's
and a
-2.
comma.
Oh, it looks like a 3.
Yeah, that's my good writing, Nick.
Oh, I didn't see that.
It's because I never got my pen licence when I was at primary school.
Absolute maximum is 18.
I just waited till I got to the next grade and I just used the pen anyway. And nobody asked, so.
I never officially did.
All right, so let's do a textbook question.
I took too long. So it's like, so,
Is it right word you got?
that is so cute.
Is that right word you got?
Here's your pen license.
All right, example 25 in the textbook. I'm going to read that. It tells us about a cylinder. It says a cylindrical tin canister closed at both ends has a surface area of 100 centimetres squared. All right, so the surface area is 100 centimetres squared. Find the correct to 2 decimal places the gradient of the volume it can have if the radius of the canister can be at most 2 centimetres, and find that gradient volume. All right, so the other thing that we were told is that there's a domain restriction, and the domain in this case is our radius, and our radius it's got to be between 0, well 0 we can't have included 0 because you don't have a circle there if you don't have a radius. And it says at most 2, so at most, is that including or not?
Most, yeah.
Including, yep. So we've got that. All right, what else do we know? What else is it talking about? It talks about the greatest volume, so volume we're after. All right, and for a cylinder, pi r squared h. And if you can't remember, on the formula sheet that you get given, there's always, they call it mensuration, which has got all these kinds of formulas, and people always look and say, what's it there for? Well, that's what it's there for, in case we've got something like that. All right. So we're after, in the end, the maximum volume. All right, okay. So we want the max volume. And what we know from our calculus, maximums occur when the derivative is 0, yes?
Yep.
Maximums occur up here
Yeah.
when the derivative gradient is
0.
0. Alright, so max volume, it says maximum volume, So whenever it says maximum volume, we talk about the derivative of the volume. And here they talk about the radius, so dV/dr is equal to 0. Alright, so that's all stuff we've got. We've got a bit of an issue at the moment in that we've got the height here. So we need to somehow get something that's going to help us with that height, because we only need volume and radius, and I've only got volume, radius and height. And that's where the surface area comes in. Because surface area, again this would be on the formula sheet, of a cylinder is 2 pi r squared, that's the area of the two ends, plus 2 pi r h. So this has got the radius in it, it's also got the height in it, and we're told that it's 100 centimetres. So what we can do is rearrange that. So if I make this 100 centimetres, rearrange that to get an expression for the height. And then put that in there. Alright, so first of all, move this stuff. 100 minus 2 pi r squared. Alright, looks, you know, because of all the 2's and the pi's and the r squareds and all the rest of it, looks very complicated. Yes, Ethan?
Isn't the 100 squared? Or
Which
is that
one?
just, is centimetres squared just the unit?
It's the unit, yeah.
Okay.
So in the end, when we get to volume, we're going to put it in centimetres cubed for our final answer. So while we're doing the calculation, we don't need to do that, but we do at the end. Alright, so then 2 pi r. So, you know, you try not to, like I've said a few times, try not to let the way that it looks complicated distract you from what you need to do. Alright, we need to get the h by itself, so we just follow the same processes as if we had something simple. Something simple like that. It's the same processes. Take this, divide by that. Alright, so if I'm dividing by all of that stuff, and that's what the height is. So now I'm going to take all of that, like I said, I'm going to take all of that, and all of that is going to go in here. So when I do that, the volume is pi r squared times 100 minus 2 pi r squared.
Did you take the 2 out?
Okay,
Did you take the 2 out?
what to?
So you end up with 50 minus pi r
Yep.
squared.
Yep, I'll get, yep, alright, we'll get to that. Good point. So, Alice is saying 2 pi r squared, take a 2 out here, 50 minus pi r squared. Good point. Because when we do that, those 2's can cancel, those pi's can cancel, and this r cancels with one of those 2. So what do we get? We've got r outside of 50 minus pi r squared. So there's our volume equation. Alright, now we've got to differentiate that. And there's a number of different ways you can do it. You can use the product rule, or you can do what I'm going to do and multiply that r in, and you get 50r minus pi r cubed, and then you can just use the x to the n. It's a little bit easier. Because the question, just referring back, the question's asking about the greatest volume, maximum volume, so I'm looking for the derivative to equal 0. So our derivative, dv dr, would be 50 minus 3 pi r squared. Alright. All with me so far? Yes? Nothing that you need clarifying before we move on?
Yeah. No, don't wait. Figure it out, so.
Wait, can you just explain how the square got cancelled out?
Which square?
That
This one here,
Because an R.
because it's r squared, it's r times r,
Oh, yeah.
and I got 1r down there,
Oh, yeah.
so it cancels with one of them.
Yeah, okay, cool.
So it just leaves me with the r.
Sorry, I thought the whole thing was S on it.
Yeah, no.
It's okay now. Yeah,
So I'll just cross the squared out. All right, so when that is equal to 0, so we got 50 minus 3 pi r squared equaling 0. Do a bit of rearrangements there. And so, what do we get?
Now, are we still going with that same question?
Sorry?
We're still going with that same question.
Because we need to find out the radius, where the maximum volume is, so that we can then put that in to here to find the maximum volume. So the maximum volume occurs when the VDR is equal to 0.
Yeah.
So a bit more taking 50 from both sides and then dividing by -1, we get that. Then dividing by 3 pi, we get r squared as that. And then when we square root, don't forget plus or minus, is that. All right.
Hang on. What happened to your negative?
Right, what happens to the negative? Which negative?
Divide by
The negative that
Ah.
that you,
All right, this one that was here,
yeah.
and then I took 50 and then I divided by -1. That's what happened to it.
Yeah.
I did it all at once in my head, that's all right. You're supposed to ask if you don't follow what I've done. All right, so now we've got plus or minus the square root of 50
You're
over 3
welcome,
pi.
people watching it.
So, yeah, well, someone else might, all my massive number of followers on
Yeah.
YouTube,
Yeah. You are welcome.
there might be some of them.
Lucky sheep.
So it's lucky that the question was asked, because, you know, they don't get that opportunity, do they,
Get
to
a,
ask?
get a sponsor for this ad break.
Can you,
Sponsor for the ad break. I could have a sponsor, yeah.
can you do that? Can you just divide it by -1 on both sides?
Why not?
Well, the point is that there's
As
a
long as you
negative
do it
on each
both
side.
sides.
They're both kind of redundant.
Yeah, but could you just do it the same way? Like, could you just make it negative just for shits and gigs?
You won't be able to do it.
Why not?
It'll be
Why make it
negative next to
positive?
square
If I had have said, all right, instead of taking 50, I'm going to add that, I would have got 50 equals 3 pi r squared. Which is same, but flipped. Different, correct.
would have been same exercise.
So you're going to, in the end, get the same result. Now, can I get to this bit?
Yeah.
What do you notice about this?
Plus or minus.
And what's the problem with that, Laura?
It's, yeah, there could be one.
Yeah,
The
and there is one.
You
Can't have a negative.
You can't have a
The
negative.
negative, yes, can't have a negative radius.
What? Oh, actually, don't worry. Yep.
No negative radius. Oops. Alright, so we are now saying then that the radius has got to be
Well, but if
root
that-
50
is that the question?
over 3 pi.
That's the question.
Now, sometimes they might try and be a little bit tricky because we've got a domain for our radius. So rather than just assuming that this is going to fit in, we should just do a little bit of a quick check. And if you do 50 divided by 3 pi and then square root it, because I've done this earlier, that's approximately 2.3, which is out of the domain. It's further than the domain, it's past this. So if it's past this,
Is it undefined?
no,
Then
Good.
the radius has to
So was
be 2.
undefined.
correct.
Then what?
Sorry, doesn't exist.
Right, the highest part in our domain is 2. Here it says this is about 2.3, which is outside of our domain, so we need to use the closest to 2.3 in our domain. The closest to 2.3 in our domain is 2. Alright, so, which is outside our domain. Thus we use radius equals 2 centimetres. Alright, and so on the exams, this domain stuff is very important on the exams. At the end of the year, they try and do some tricky stuff with domains to catch people out.
So with that, you can just round down.
Because the end of our domain is 2.
So, yeah.
So we're going from 0 all the way up to 2, and that's the furthest we get.
So all of that, the answer's 2.
Oh, yes, now, because the 2.3 is out here and we're not using out here.
So does that mean the graph
Waste
would
of
look like
time.
a circle but a tiny bit of the top's cut off, so it's actually just like a funny U shape? Oh.
Yeah,
So
so
really,
instead
the
of
question's
going,
wrong.
us getting to this point, we're only going to get to,
And it would cut off across both sides.
yeah, so we wouldn't get that part there.
That's funny.
So within our domain,
So a question like that would definitely not be on the non-calculator exam. because
no,
there
it'd
is
be
no
more
way that
likely
I'm
be a
gonna-
calculator one and a number of parts.
Yeah. So like what we've just done
That could be
Would
like
be
4 or
separate.
5 parts.
could,
All right, so in the end we were asked for the maximum volume. So our maximum volume in our domain is 50 times 2 minus pi times 2 cubed. And that would be 100 minus 8 pi centimetres cubed. And if they asked for exact value, you would leave it as that. If it asked for 2 decimal places, you'd say then that it's 74.87 centimetres cubed. All right. And that's it. All right, so the next couple of exercises, C and D, D, E and F, E and F, is to do with that maximum stuff, and then Friday we'll finish off chapter 10. As I said to Alice before, we're just running a little bit behind.